My name is Marcus Placona. I'm a developer evangelist for a company called Twilio. I think by now most of you would have seen us outside on the booth. Does anyone not know what Twilio does? Okay, cool. So Twilio is a communications API that helps developers like yourselves adding SMS messages, like sending and receiving SMS messages. We do IP communications as well. We do VoIP, and we do making and receiving telephone calls. These are SMS messages and telephone calls to be done from the applications you're already building using the languages you already know. So we have libraries for everything. We have SDKs for everything. And the idea is just like it's a REST API, so you can just go and use that if you need to communicate with your customers or something from within your application. But I'm not here to talk about Twilio today. We have a booth, as I said, just outside. If you want to learn more, if you want to get a cool T-shirt, we have a booth just outside. Here's some information about me. So I'm Marcus Placona. Here's my Twitter account. Here's my GitHub account. GitHub account is important because if you want to see some of the examples I gave you here today, you can get those from my GitHub account. Everything is open source. Everything's ready for you to go and download. And I also run a website called AndroidThings.rocks, which is a website about Android things. So every one of the experiments or every one of like the getting started things and all my experiences with it will be on AndroidThings.rocks. So if you want to learn more after this talk, if there's anything you feel like you haven't got, you will probably find it on AndroidThings.rocks. And the last thing I'm going to say is I am going to be publishing those slides later. So don't feel like you need to be taking pictures or anything. You can, but I am going to be publishing those slides later, so you can get them all later. Now, can I just get a show of hands of who's done anything with Android things before? Okay, so only 3 people maybe. Cool. So let me tell you what Android Thing is, and we can just go from there. So Android Things is an extension of the Android platform. So you've probably seen Android running on things like telephones and watches and TVs and sometimes cars. But most of you haven't seen Android actually running on devices, just regular devices like Raspberry Pis, for example, or your microcontrollers. And this is exactly what you can do right now. So Android Things is basically another version of Linux that you can install inside your devices, and now you can run Android. The beauty of it is you can run the same Androids that you've already written, or the same Androids that you've been writing, and the same Androids that you know, which makes it very powerful. Some of the applications for this, and we're going to look at codes as well, but some of the most common applications for this are things like cameras or points of sale, like if you have a till and you actually want to have control of it. Security systems, like if you want to build cameras, if you want to have like buttons and things, we're going to look into some of those as well. Or like if you have asset tracking. So I've seen people doing like fleet management, for example, where they actually have an IoT device inside the truck and they can tell where this truck is. They can get GPS coordinates and all that. But the most interesting thing about Android things, in my opinion, is it runs on all the places and it uses all the tools that you already have as an Android developer. So you can build Android things applications using your Android Studio. It's obviously running in Android. You can use Google Clouds. You can even use Kotlin. I am going to be using some Kotlin today to show you some of the examples. But obviously, if you want to do it in Java, you're more than welcome to doing that in Java. It's basically whatever you're most comfortable with. And now you have a new set of APIs that you can use to control external things. But where does it run? So where is it I can actually have Android things running? Because I'm here telling you that you can now go outside of the telephones and you can now go outside of the cars and everything. So where does it actually run? Which boards can you get this to run? If I was giving you this talk maybe 3-4 months ago, I would have showed you these slides. I would say it runs on the Intel Edison, the XAO, the NXP Pico, and the Raspberry Pi 3. Some things have changed since June because basically 2 of these boards have been deceased. So I don't know if you follow that, but Intel, which was the company actually working with those boards, they decided to kind of go out of the IoT market with these specific boards, okay? Which basically means now you have 2 less boards where you can run Android things. You can still run it on the NXP and you can still run it on the Raspberry Pi. Here's just a link to an article where Intel is saying we're not going to be running these IoT boards anymore. As it turns out, those boards were just too expensive. So it was really, really expensive to actually get those boards. But one company actually caught up with this, which is NXP. And NXP went and released 2 more boards, which is this one and this one. So if you look at the pricing for these boards, they're actually very comparable to what a Raspberry Pi is. So I don't know how many people have a Raspberry Pi. You will have been used to pay something like 35 euros for it. With the NXP Pico, you can pay the same thing, okay? Now, I have to say, though, that out of all these boards, my favorite board is actually the Android board. Sorry, the Raspberry Pi board. They all run Android. It's actually the Raspberry Pi boards. The reason the Raspberry Pi boards is my favorite is that I can almost guarantee that some of you here will have this board already. It's probably in a drawer, gathering dust, not doing anything, okay? This is how my boards work. And you probably don't have any of these boards here because, first, some of them are slightly more expensive and they're not as easy to find as just going to a website or going to Amazon.com and buying a Raspberry Pi. So you can get a Raspberry Pi 3 almost anywhere. So my favorite board is the Raspberry Pi 3, and we're going to look into why that board is my favorite. First one is community, okay? There's a bunch of people building things with Raspberry Pi 3s. Or Raspberry Pis in general, okay? So every time I get a problem, every time there's an issue with something, GPIOs and stuff, we're going to look at GPIOs later as well, but every time there's an issue, I can just go to a forum and I can ask the question. And there's always going to be someone to ask me, to help me with it. Whereas with the other boards, because they're fairly new, it's just not as easy. The second reason for me is I'm okay with putting something like 35 euros behind, I don't know, a door or something. If I'm building a doorbell or if I have a camera, so I'm okay with putting 35 euros on it. I'm not really okay with paying 65, 80, 100 euros to get a board that does the same thing and stays there as my doorbell, for example. So the Raspberry Pis are very accessible. I have seen a lot of people doing workshops using Raspberry Pis, and most times when people go to these workshops, they already have a board. Okay, very accessible, very easy to find. So these are like the reasons I usually go with the Raspberry Pi. The other boards are just as good. But now, how do you get started? Because obviously I told you about the boards and everything. So what to do to get started? What is involved in this? Because you're now basically installing Android in a board. You're installing Android in a Raspberry Pi, whereas previously you didn't have to install Android. You had a phone and it had Android on it. So how do you get that? How do you get started? Well, the first thing you're going to need is obviously a board. So you're going to need a Raspberry Pi. The second thing you are going to need, which you probably already have, is Android Studio. So you just need to have Android Studio installed. You don't really need to have anything else installed. But now you want to make sure that you can get Android Studio to talk to your board here. So what you do about that is you get a memory card. So most Raspberry Pis will already come with the memory cards, but you get memory cards like this, and you're going to burn the image into the memory card. Okay, so this is the command that you should be running if you are using something like a Mac, for example. There are other tools you can use. There are tools like Etcher, for example, that will just do it for you manually, automatically. So you just literally drag the file into it, and it will etch the image. So it will burn the image into your memory card. So once you've done that, this is what's going to happen. You're going to wait, okay? That's going to take a while. It can take anything, depending on like the speeds of your memory cards. It can take anything from 5 minutes to 20 minutes. So I've seen it taking 20 minutes. So I usually just tell people, go get a cup of tea, just go get some coffee, and just leave it doing its thing, because it doesn't really give you any feedback of like, oh yeah, it's going to take me like 20 more minutes or 5 more minutes. So you're just basically waiting for this, okay? But this is it. Like once that's done, you will put this memory card into your board, so in this case, into your Raspberry Pi, and you're going to end up with a screen that looks like this, okay? It will say no Wi-Fi connection because you're not connected to Wi-Fi. In this case, I was connected to an Ethernet cable. So the first time you boot it up, it's obviously not configured, so you need to have it connected to an Ethernet cable, to a hardwired cable. And that's it. So at this point, you can configure Wi-Fi as well. So there's nothing special about configuring Wi-Fi because all these boards come with Wi-Fi enabled. So you just need to configure your SSID and your passwords, and there you go. You will have Wi-Fi connected. But I think that, like, instead of just showing you and telling you what to do and everything, I feel like I should give you a demo of, like, okay, so how do these boards actually work and what happens? So I am gonna leave my presentation here, and I'm gonna open up my IDE, and I'm gonna make sure I'm sharing the screen. Cool. So what you can see right here is, you can see I have a Raspberry Pi, so you can see my finger going on, so you know I'm not faking this. This is real. So you can see I have a Raspberry Pi here. I have a button connected to it, okay? And this is all I have. And I have this thing hardwired to my laptop because I didn't want to rely on the Wi-Fi, because the Wi-Fi has been, you know, it's had its ups and downs here. So I didn't want to rely on the Wi-Fi. I have a project here, which if you're an Android developer, you will have seen this before. So right here, I have my Gradle file. So this is my build.gradle. So this is the application level. And what I'm going to have to do is, so this is a Kotlin project. There's nothing special about it. So I have a manifest, which you get when you start a new Gradle file, when you start a new Android application. And then I have this file here, which has an onCreate. It doesn't do anything, okay? It doesn't do anything at all yet. So what I'm going to do is I'm going to try and see if I can upload an application to my Raspberry Pi here. So the first thing I need to do is I need to go into my builds file, and I'm going to add a reference to Android things. So I'm going to add a dependency to Android things, okay? So not doing anything special here, haven't downloaded anything special. I'm just adding a reference to Android things. The next thing I'm going to do is I'm going to add a reference to button as well. So here's the difference between buttons and the buttons you are used to when it comes to being an Android developer, like the widget buttons. In here, we're actually using a library. It's a driver library to be able to control buttons. Because we have external buttons now. We're no longer using widgets here. We're using buttons that look like this. Okay, so I want to be able to press this. I want to be able to use an external button. So this is why we're adding this extra library here. I'm going to let this thing sync, and I'm going to move on to my manifest file. On the manifest file, this is important as well. When one of these devices boots, because you don't have any interface like a phone to actually open up the library, to actually open up the application, you want to tell it to boot automatically. So you want to tell it to open the application automatically for you. So in that case, for example, imagine I gave you an example of having a fleet, for example, like a fleet of trucks. If you have this thing inside a truck, you're probably not going to have a screen where you can just go and open the application. So you want to make sure that whenever the device boots, the application opens up automatically. To do that, we're just going to add a new intent filter here, which basically says, okay, so I'm using the IoT launcher, and every single time I boot this device, I want to make sure that this application gets launched. So this is the application that runs as soon as the device is started. Cool. So I'm on my main. Who's writing Kotlin code here? Awesome. So I'm on my main application here. I'm on the main activity, and what I am going to do is I'm going to start real simple here. I'm going to start by trying to get access to the GPIO. We'll talk about GPIO later, but GPIO is basically your general purpose input and output. So this is the thing you use to control your buttons, to control your LEDs. So all the things that are actually plugged to your board. So I'll create a variable here. I'm going to call that service, and I am just going to create. I'm just going to get the peripheral manager service. Okay, so this is how you manage peripherals inside Android things, and I'm just going to log what GPIOs I have available to me. So I'm going to call that GPIOs, And inside of here, I'm going to go service.gpio list. Okay, so I just want to get a list of what GPIOs are available to me. And just remembering, I'm going to get a list of what GPIOs are available in these boards here. So if I go ahead and run this application, as you can see, it already knows that I have an Android device connected to it. Okay, so it's called Google IoT, Raspberry Pi. So I have an Android device connected to it. So I don't need to do anything special, and I'm going to click OK. And hopefully what's going to happen is, at the bottom here, you will see that when this thing finishes compiling, we get to list all the GPIOs. So it says Gradle build running right now, so it should be done in just a bit. So it's usually quick. It depends on the, yeah, okay, so that's installing the APKs. Good. So if you look at the bottom here, you see GPIOs. And these are basically everything that is available to me. So these are all the things I can connect external hardware to. So I have BCM 12, 13, 16, 17. So I have all these ports, all these pins I can actually connect hardware to. Great. So we've looked at the, this is sort of the hello world for me. Okay, so this is like, okay, we know we're connected to this thing and we know it's running. So let's go back to the slides and we'll come back here later. Because I didn't know if the Wi-Fi was going to work, I actually had a backup here, just in case I had a video. I think we can skip that because we know it worked. So, good. We haven't been using any hardware so far. So we only use this external hardware. We only use these boards. But we haven't actually, even though we imported a button, for example, we haven't actually used any buttons here. We haven't used any LEDs. We haven't used anything else. So who's been playing with hardware? That's great. Cool. So for whoever's not been playing with hardware, if you've been playing with hardware, some of these will be repetitive to you. If you've not, some of these may be new to you. So one of the things that we looked at so far is what a Raspberry Pi actually looks like. So this is the board. Okay, so this is what a Raspberry Pi looks like. And the Raspberry Pi has all of these pins here. So some of these pins are GPIO, some of them are for power. You have some grounds. You have I2C, for example, if you want to communicate with some external sensors. So each sensor and each external bit of hardware will have a need here. So some of them will just use the regular GPIO. Some of them will use something like I2C. But this is basically, this thing represents all the pins you have in here. Okay? Now, the other thing that you're going to see quite often is you will see stuff like breadboards, for example. And breadboards are basically a construction base for you, okay? So imagine a breadboard being like your playground where you can connect LEDs in, you can connect sensors in, for example, but you're not doing any soldering. So this is the place where you can connect stuff without committing too much. Because if you connect something here and you say, well, that didn't quite work, you're not making any commitments. You can move stuff around. So each one of these little holes in here are places where you can connect things. And usually what you're going to do is you're going to end up connecting things like jumper wires, for example. You are going to connecting things like resistors. So just to kind of go on jumper wires are basically a way to go from one sensor to a board, for example. So it's just a piece of wire, okay, that you can connect. Resistors. Resistors are important because if you have LEDs, for example, and you want to make sure that you don't blow up your LEDs or you don't like see that magic smoke when you connect it, you are going to have to use resistors because resistors basically control the resistance that actually goes into your external bits of hardware. So as it turns out, and I learned this the hard way, the colors in the resistors actually matter. When I looked at this for the first time, I was like, oh yeah, this is cool. I'm just going to use this one because I like the color. So the colors actually matter, okay? So with resistors, you're going to want to make sure that you're using the correct values. And in most examples you find out there, or even documentation for sensors, they will tell you what resistors you should use, like what values you should use. And then you're going to end up looking at a board that looks like this, a table that looks like this, and it will tell you what resistors to use. And LEDs are just the shiny things, okay? LEDs are the blinky things where you have an anode, which is your positive side, and a cathode, which is the negative side. So if you connect them the wrong way, they are going to blow up, okay? If you connect them to too much power, for example, if you put like LEDs in 5-volt straight, or if you go crazy and connect it to the mains, they're going to blow up, okay? So obviously resistors are there to help you out with this. So I always recommend, if you're getting started with it, everything in here is really cheap. Everything in here together will cost you less than €5, okay? So it's not this is not a crazy start. You're not making a big commitment. But, you know, if you want to get everything together, it is going to cost you less than €5. And I always say, just get a bunch of this. Just keep a bunch of this lying around, because you're going to be using different values here. You're going to be using different colors here. So if you're going to get it, just get a bunch and just keep them around. The other thing that you're going to see when it comes to not only Android things, but to IoT in general, you are going to see some diagrams that look like this. And these diagrams are great because they tell you exactly how to connect things here. So in this example, we have a button. That button needs a resistor. It even tells me the color of this resistor. So this is brown, black, orange. And it tells you exactly where to connect, which pins you're going to use to connect. So you're not going to make any mistakes here. All of these examples are done using a tool called Fritzing. And Fritzing is a free and open source tool that helps you do exactly this. It's basically a drag and drop tool, okay? So in every GitHub example, if you go to the androidthings.rocks, which is the website I mentioned before, you are going to see that we have these kind of examples in there. And those are really useful because you can, it's almost like copy and pasting, but you're just like, you know, you're just copying what's going on in here. Let's look at a demo for this as well. Let's look at how a button actually works. So coming off my slides here and back into my Android Studio, I have connected the button here for you to see. And as you can see, I basically just have a button in here. That button is connected to my board. Okay, so there's nothing special. It's connected the exact same way as I just showed you back there. And this is what my breadboards is. I just got a red breadboards. You can get them in all sorts of different colors as well, which is kind of cool. But obviously, right now, if I press this button, nothing really is going to happen because I haven't programmed this button. I haven't done anything. It's only connected, but I didn't really say what should happen if someone presses the button. So this is the same idea as if you're an Android developer, if you're an iOS developer. This is the same idea. Like if you just have a button in there and you don't hook it up to anything, you're going to click it and it's not going to do anything. So I'll make a little change here to my application. So the first thing I'm going to do is I'll create a late init var, which I'm going to call button, and this is also going to be of type button. So this is really important. As you can see, you have two options here to choose what button you're going to use. You have the Android widget option, and you have the com.google.androidthings. You want to choose the second one because this is not a widget, so this button we're using is an external button, so we want to use the driver. If you try and use the widget, this isn't going to work for you, okay? So I've just created a variable for my button, and now I want to create this button. So button equals button. And I need to tell Android things where this button is connected to, which pin this button is connected to. So I know that I've connected it to BCM6. So this is one of the GPIOs on my application. And I also want to tell Android things what the logic state is for this button, because there's a time when you press the button and there's a time when you release the button. So I'm going to go logic state and I'll say pressed when low. So I want to do something when someone presses the button, not when they release it. So pressed when low. The next thing I'm going to do is I'm just going to create a callback here. So I'll use my button, and I'll just create an event listener for this. And the event listener is basically, okay, so what happens when someone presses this button? Because so far, I've only declared the button and creates this, but I haven't done anything about when someone goes and presses this button. So I'll do that. I'll keep it simple and I'll just move this bit here. So what I'm doing here is every single time I press the button, I just want to log a message that looks like this, okay? And I'll change that to say something like pressed, okay? Because now I know that I pressed the button. You will notice that I have a close function at the bottom here. And the close is whenever I use an external hardware, I want to make sure that I close it. I want to make sure that if my application closes, if my application dies, I want to make sure that I close the external hardware here. So this is just so you're telling the hardware, you're not in use anymore. If I need to use that pin is free. So I'll just go button.close. This is the great thing about Kotlin as well, because I don't need to do like try catches here. I don't need to check that this button is not null. So I know it's not null in this case, so I don't need to do anything special here. And I'm going to go ahead and run this. And I think it's, yeah, it's installing the APK and launching the activity. I seem to have an error here, so I probably did something wrong. Okay, yeah, so BCM6 is already in use. Yeah, this happened to me before. And this is exactly the thing I just said. Like, if you're using a pin, if you have used the pin, and I have used this pin before, because I was basically just checking that this code worked, you're going to get an error like this. So I forgot to close this before. So what I'm going to do is I'm just going to very quickly change this to another pin. So I'm going to change this to pin 5. And change here to 5. And now if I run this, it should work again. It's a good thing I was prepared for this, because awesome. So it's in error, so you can see that it didn't do anything. It didn't log the GPIO this time. And what I wanted to do is I want that every time I press this button, I want to make sure that I log something to the bottom. So I'm hoping this is what it's going to do now. Yeah. So now every time I press it, it will log. Okay. So this is me just interfacing with an external button here. So this is going to the external hardware. This could have been anything. Okay. This could have been your doorbell. This could have been a light. This could have been anything else. It doesn't, it doesn't need to be a blue button. This could be anything. Cool. Going back to the slides here, we looked at what this external hardware actually looks like. Again, for this I had a backup just in case things went wrong. You can see I'm doing the same thing here. You can see my finger just going and pressing this button. That's the same idea. Cool. But this is the point where people just get confused, because I talked about not using widget buttons. I said, let's use a driver button. And like, what is managed by who here? Like, who manages these drivers? Who manages the widgets and everything? Like, how does that work? So this is the codes I just showed you, okay? So what is managed by Google is obviously the Android framework, okay, as it's always been. The hardware libraries, some of the hardware libraries are managed by Google, and the Linux kernel. Managed by developers are the apps that you have and the user drivers. So as it turns out, you can create your own drivers. We used a button driver here, which was created by Google, but you can also create your own drivers. So I'm just kind of pointing out here. I know it's hard to see, but I'm kind of pointing out that, okay, so Android.things.pio is the thing that is managed by Google, okay? And the thing below, right now it's managed by Google, but it's also open source. So if you want to make changes to it, if you find there's a bug with it, it's also open source, so you can go and change. And right now there's a bunch of different libraries out there. So you have a library for servos. You have a library for if you wanna use LCDs, for example, like LCD displays. You have drivers for buttons, as you can see here, GPS, all the sorts of libraries. Okay. But the best thing about this is which is the thing I like the most. Well, this is a GitHub page. Okay, so it's all open source. You can send pull requests to this. But the best thing is, there's people actually writing drivers. There's people actually writing about writing drivers, which is really cool. Because if you are using a piece of hardware, if you are trying to use something that is not supported by Google or that is not already supported in the Android Things framework, you can just go ahead and write that yourself. So in this example, I wrote, so there's this chip called MAX7219, which is a chip that helps you controlling up to 64 LEDs. And I wanted to be able to control up to 64 LEDs for whatever reason, but I wanted to do that. So what I did was I went and created my own library. It's also open source, it's also on GitHub. Anyone who wants to contribute to this can just go ahead and contribute. Now, looking at things that are managed by Google, this is what Android is on your phone, okay? So if you are using an Android phone, this is what Android is right now on your phone. When it comes to using Android things, you will notice that you will have lesser options. So you don't have a launcher, for example. You don't have a phone, like you don't have a phone app. You don't do messaging, contacts, calendar, browser. You don't need any of those things, okay? Because you're now running on an external device, and you probably don't need access to your contacts from the external device. And displays are also optional. So this is the other difference, because you've been using Android on a phone, and obviously your phone has a display. In this case, displays are also optional. You don't need to have a display. The example I showed you so far has not used any kind of displays, and I think this is great. However, if you want to see what your application is doing, I have seen people building applications that mix and match the two things. I have seen people building applications that have external buttons and widget buttons, and that's totally okay. You can build applications with that. You can get a Raspberry Pi screen, but if you're testing and you don't have a Raspberry Pi screen, you can use Visor. Everyone knows Visor here? Cool. So Visor is an Android tool that you can use that as a simulator. So you can use that to see what you can see on a device screen. You can use that to see what you can see on your phone screen. So the great thing about this is, because a Raspberry Pi or any of the Android Things devices don't have an emulator and they don't have a screen, you're going to be running things here, and you'll be like, okay, but what's going on? Like, what is this thing displaying? With Visor, you can see what is being displayed, or what would be displayed on your Android Things. You can also use that with Android phones. So if you have an Android phone and you want to plug it to your computer, you can use Visor so you can see that. This is also a free application, okay? But I want to show you another demo, because I want to show you like something I actually built for myself. And I'm going to tell a little story here about why I built this thing. I work from home, okay? And when working from home, I usually have my headphones on. So I'm sure I'm not the only one who does that. So I usually have my headphones on. And if the postman comes over and rings my doorbell, I never see that. I never hear that because I have my headphones on. Okay, so I'm on the top floor and I never hear that. So I just end up missing a bunch of parcels. I thought, okay, so what is the one thing when I'm working from home that is always in front of me? There's two things actually. There's obviously my computer. I'm working on my screen, and I always have my phone. My phone is always in front of me, okay? So I miss parcel deliveries, but I never miss any calls because my phone is in front of me. So I built this thing called the Smart Doorbell, and it's basically me hacking my own doorbell. So when someone rings my doorbell, my phone also rings. And this is the thing I'm going to show you. I'm going to show you here. Okay, so I built this thing basically for my own benefits. I wrote a blog post about this, so you can if you can look it up and see how it is. So let me go back here and change to my ID. I'll stop this. And I think this is also a good example because it shows you that, well, this is just an app as you're used to if you're an Android developer. I am using the same things I've used before, so I'm using Android Things here, I'm using a button, and I'm using retrofit. So you can use most of the libraries you can use with Android, you will be able to use here. Obviously, if it's an interface library, again, this thing has no screens. If you have a screen, then you can use that. But most of the other libraries you use, so retrofit, for example, is used to make HTTP requests. It's used to call APIs. So I've got retrofit, I've got my doorbell, so I've got my interface here, and I'm just saying, okay, so I want to make a request to a call API. So I want to make an API request to a URL that has /co in it. And here's what the code, here's the code I wrote. This example was written in Java. I also want to show you that. You can do Kotlin, you can do Java. It doesn't really matter. So I have a base URL here, which is what I'm going to be calling. Instantiating my retrofit here. So I'm just creating a new retrofit instance. And I have all the logic around my button. So I changed that to BCM6. So I should BCM5. So I should probably change it here too. So I'm doing the exact same things. I have some logic around my button. When you press the button, what happens? Okay. And obviously, I am going to have to show you this in this button because, like, I wish I could bring my house here to show you, like, on my house, but that isn't going to work for me. So I'm just going to show you in this button. But imagine, just use your imagination to think, yeah, this is actually my doorbell. And when I run this, and I'm going to get my phone out because this should actually put my phone in my bag. I want you to hear my phone ringing when I press the button. Find my phone. Maybe I should just make it ring. Well, I cannot find my phone. Yeah, exactly. It will ring, right? Okay, yeah, I'll do this. Yeah, I'll press the button and then it will ring and I'll find it. Cool, so I've got the application here and I am going to run it on the device. And as soon as I run, I should be able to just press the button. Yeah, okay, so this is actually a good example because I can use this as a find my phone thing. Okay, so this is in there. It's looking good. Now it's see. Oh, here we are. Okay, my camera crashed now. This is all going. Okay, let's start again. It's presenter. Cool. So you can still see this, and hopefully, if I press the button, I should now find my phone. So as you can see at the bottom, it says button pressed. And hopefully my phone is here. This wouldn't be a good time to lose my phone. Okay, I just have no idea where my phone is, so that's gonna be a problem. That's gonna bug me now. Well, my phone is ringing somewhere. My phone is ringing somewhere. I have no idea where it is now. I usually leave it with me, but I have no idea where it is. My phone is ringing somewhere, so you're going to have to trust me on this. But basically what it does is, my phone is in front of me, my phone rings, and when my phone rings, when I answer it, it will say there's somebody at the door. So I know that it's not just my phone ringing, but there's actually, there's actually somebody at the door. So yeah, I'm sorry for this. I wish I could show you on the phone, but oh, my phone is here. And I have a missed call. Okay, let's try again. So hopefully, if the internet, yeah. Did you hear that? Okay, yeah. So this is okay. So it's good. I found my phone. So that's this is nice. Cool. So going back to my slides here, this was a roller coaster of emotions right here. Cool. Let's just talk. Let's just talk about some different examples because I have been building a bunch of things with this. I got too excited, and then this one day I was like, "What if I could get a high five every time someone follows me on Twitter?" Okay, I'm an avid Twitter user, and I actually built a Highfive machine. It doesn't quite look like this, okay? It's more of a Highfive machine, but I actually built a Highfive machine where every single time someone follows me on Twitter, I get this little hands that goes, high five. And this is like, this was my attempt of actually trying to use different things. So I was trying to use Firebase on this, for example. So I have a Firebase I have Firebase actually listening to my Twitter feeds, and whenever there's a new follower, I just get a high five, which is really cool. I also built stuff like controlling your office lights. So this was my attempt of controlling my Philips Hue lights. I have Philips Hue lights in my office, and I was like, well, I want to be able to press a button and turn it green. Sure enough, I could just say, Alexa, turn the lights red, for example. But I just wanted to go back. I just wanted to be able to press a button, okay? And yes, this is all possible because there's an API for that. So there's different things you can do. There's everything that you can control with this as well. Now, to kind of close this up, this is Android Things. It is powered by Android, which is awesome. It is managed by Google because you can do OTA updates. You can do over-the-air updates to your boards. You don't need to get your boards and just put it somewhere. And it's automatic and secure because it's obviously managed by Google. With that, I've been Marcos Placona. Thank you very much.